The salary of members of two governing bodies in 2008 was $164.60 and 6,000, and 6,000, and has increased by approximately 2,000 per year since then. Okay. Now, when you encounter this piece of problem, um, this is a linear model. This is a linear modeling problem. Okay. And when you talk about linear modeling, the first thing that comes to mind should be your y is equal to mx plus your b. Is that okay? Now, your m is always your slope, right? And another name for the slope is your rate of change. Is that okay? And your b is the starting point. The fixed number. The initial number or the constant. So these are names that are used to describe your y-intercept. All right, all these refer to the y-intercept. So we're going to use these definitions to deconstruct the problem that we have. Okay, so the salary of members of two governing bodies in 2008 was 164.6 thousand and has increased, right? So we ask ourselves, and has increased by 2,000 per year since then. So we are going to write y. Now, what is the rate of change? What has been changing? The numbers that are given in the problem here. Which of these two numbers has been changing? And you notice that 2,000, right? So 2 is the one that has been changing, the rate of change. So that becomes your m, your slope becomes 2. Is that okay? So let's bring x. Now plus, what is b? So b is the starting point. So two governing bodies in 2008 started at, that was the initial, so that becomes 164.6 thousand, and that is your equation. Is that okay? So now that you have this equation, you can come to this side of the table and work on the problem. So you're going to use this equation, okay, to complete the table. So what this means is that years since 2008. So since 2008 is the starting year, that takes the value 0. So the starting year, what this means is that you plug in 0 for your x, and you have that. Year number 1, that is 2009, you plug in 1. Year number 2, 2010, and so on and so forth. So because this wants us to express this, because it says that your x should be a time, we could rewrite this as that. Okay, it means the same thing. All right, they are just interchanging variables. You're saying that x should be t, and that's it. So that is where you come and then you write that. Okay, nice. Now b, evaluate the expression that is found in part A for t is equal to 5. Now for t is equal to 5, all you need to do is to plug in 5 for your t. Okay, and your answer is what? 174.6 thousand. Okay, now let me explain this. You do not have to bother so much about adding the zeros, right? Because it says that the values on this table are in thousands of dollars. So just leave your answer as that. So that is it. Now this means that the salary will be about 174. So we are trying to interpret this number, right? 174.6 thousand in which year? Now, the starting year was 2008. So 2008, if you add 5 years to 2008, right, that would be what? 2013, and that is your answer right there. Is that okay? So that is how you solve this problem. So first, you need to pull down, when you get a problem like this, know that you are dealing with linear modeling. And for linear modeling, y is equal to mx plus b, right? M stands for the slope, which is the rate of change. And then your b, which is your y-intercept. And at the y-intercept, your x is equal to 0, right? The y-intercept stands for the starting value, the fixed number, the initial number, or the constant. Is that okay? So you ask yourself these questions. Okay, what number is changing? The one that is changing becomes your slope. Okay, what number is fixed? What number is the starting? Is starting. What is the starting number? What is the initial number? What is the constant? Those should be your y-intercept. And that should be a very good guide to help you in dealing with the problem. All right, good day. Bye.